Today, we're going to walk through everything you need to know to properly install dry-type energy-efficient transformers, including the science behind how they work, how to size them correctly, how to manage temperature and wiring, and how to install them safely and efficiently. Dry-type transformers are electrical devices that step voltage up or down without using any liquid for cooling. Instead, they rely on air circulation. Before we get hands-on, we need to understand a few electrical fundamentals. We use Ohm's law, V equals Y times R, and calculate power using P equals V times I for single phase, or root 3 times V times I times power factor for three-phase systems. Transformers work using magnetic induction between primary and secondary coils. The ratio of turns in these coils determines how voltage is increased or decreased. We calculate efficiency by comparing output power to input power, and losses are mainly due to core losses and copper losses. Temperature control is critical. Dry-type transformers rely on natural or forced air cooling. We need to consider ambient temperature, temperature rise, and hotspot temperature to make sure we stay within insulation limits. Next is wire sizing. First, calculate load current using the power formula. Then refer to NEC ampacity charts to select a conductor that can safely handle that current, accounting for temperature, material, and conduit type. Refer to NEC ampacity charts to select a conductor that can safely handle that current, accounting for temperature, material, and conduit type. Finally, check voltage drop. We typically want no more than 3%. Transformer placement matters. Always provide plenty of clearance, usually 12 to 36 inches for airflow, and avoid locations with moisture or dust. Use vibration-isolated mounts and ensure the unit is service accessible. If you're at high altitude or in hot environments, you may need to derate the transformer. Transformers have labeled terminals, H1 to H3 on the high voltage side, and X1 to X3 plus X0 on the low voltage side. The H terminals are usually connected to a delta configured primary, while X terminals are in a Y configuration with X0 as neutral. The most common configuration is delta to Y. That means the primary side is delta, and the secondary is Y, giving you 3 phase lines and a neutral. Delta-delta and YY configurations also exist, each with their own pros and cons for different applications. Here's how the voltage breaks down in a 208Y/120 system. Between X1 and X0, you get 120 volts. Between X1 and X2 or X2 and X3, you get 208 volts. This allows you to run both three-phase equipment and regular 120V outlets off the same system. Transformer coils are wound with polarity in mind. H1 and X1 usually share the same polarity. That's important if you're running transformers in parallel or trying to match phase rotation. Always confirm phasing with a meter and follow the manufacturer's wiring diagram. When running transformers in parallel, matching polarity and phase rotation is crucial for proper operation and load sharing. Always ground X0 if you're using a neutral. This is crucial for safety and proper system operation. Here's the installation process. Plan your setup, size your transformer and wires, connect per the wiring diagram, and test everything before loading. Always ground X0 if you're using a neutral. Overcurrent protection, temperature sensors, and ventilation fans should all be in place before powering up. In summary, understand the electrical principles. Choose the right transformer size, keep it cool, wire it correctly, especially the H and X terminals. Place it carefully and always test and monitor after installation. Dry-type transformers are incredibly efficient and safe when installed the right way.